Welcome back to Scholarship Dudes and Math. Today we'll be working with the Euler's number. E. Yeah, the letter E is a number. So Euler's number, mathematician, or the natural base. It's irrational. And basically how it came about is they had the interest rate thing, so 1 plus 1 over n to the nth power. And what they did was they took n and took a really high number, and they kept getting this number, E, which was about 2.718281828, blah, 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 blah. So it actually came out to be a number. So every time they tried out a super high number, it gave them this number. And they're like, oh, let's use this. So whenever you run this into an equation, E is just like, just think of it as X, I guess. It's the same thing. So if we're multiplying two numbers of the same base, we just add the exponents, right? So this would be e to the 2x plus 3 plus x. So this would be e to the 3x plus 3. If we're dividing, we subtract. So 6 over 8 becomes 3 over 4. And then this is e to the 4x minus 1. Because this is e to the first down here. And then, once again, the whole exponent rules. So remember, this cube root is the same thing as 8e to the 9x. And this is all being to the 1/3. That's the same thing. So 8 to the 1/3 is 2. The cube root of 8 is 2. And then 1/3 of 9x is e to the 3x. Okay. So just remember, e is 2.7, blah, 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 blah. Just use it like a variable, like any other number. It's just a new number. Instead of 2, it's e. Okay. Alright, weird problems. So, last time we worked on compounding interest at certain intervals. Banking, they started to move on to continuously compounding interest. So it's like, I guess you can call it like every second, it just keeps doing this. So this is represented, so we had the original one, A equals P1 plus R over N and T. Now we call it PERT. A equals P R to the T. Okay? Where principal, or P is still your principal. The initial principal. The initial amount. R is your interest rate. And then time for T. So it's P times E to the RT. In your calculators, there's actually an E button. You can find it on there. It's usually like above LN. The button LN. It's usually on the left side of your calculator. You can find it. But there is a function there. So you deposit $4,000 in an account that pays 6% annual interest compounded continuously. What is the balance after 1 year, 5 years, 10 years? So we're using the formula. So P is 4,000. And then E to the RT. So 6% is R, so this is 0.06. So 0.06 times T. So for this first one, they want 1 year. The next one, 5 years, and then 10 years. So I'm going to put this into my calculator. Pause video. And we get, for the first one, 4,247.35. And then for 5 years, 5,399.44. And then 10 years, 7,288.48. So, I mean, 10 years, you make, like, you don't really make much. That's why you always gotta keep putting more money in. 6, or do some sort of investment, other investment. So you deposit $100 in an account that pays 5% annual interest. What is the balance after 10 years? Compounding annually. So remember, wait a minute. Oh, okay. So they wanted you, so this time they want you to use these formulas. So P 1 plus R over N to the NT. So ditto with part B. Part C, they want you to use PERT. Okay. So so this P equals 100. T is 10. And that's going to be for all of these. Our rate is also going to be, for all of these, 0.05. 0.05. And then you just plug it in the formula. It's not so bad for this first one. If you plug everything correctly, you should get a... What? Okay, 162.89. This is for every monthly, 164.70. And then this one is 164.87. Continuously, you get the most, it seems. Alright.